So let's take up the thin lens equations. So we're looking at these sheets here. Oh, my kids were playing with this. Looking at this sheet here, okay? All right, so let's start with number 1. I'm just going to keep it to the side. Suppose a converging lens has a focal length of 10 centimeters and an object of height 1 centimeters is placed in front of the lens at 5 centimeters. Locate the resulting image. All right, so first thing you do when we're doing these math questions is you always start with the knowns. Known, okay. Focal is 10 centimeters. It gives us the height of the object, and sometimes questions are going to give you information that you don't end up needing, but it's mostly it's there to test your knowledge. Do you actually know what it is that you need and what you're looking for? That's what's testing, okay? So it will give you questions. There will be questions where it gives you information that is useless. But it's being able to pull out the right information from the question. That is a skill in math. Okay, so we have height of object is 1 centimeter. Is placed in front of a lens at 5 centimeters. So that is object distance. So DO is 5 centimeters. Okay, and then we're looking for the resulting image, which is our DI, which is what we don't know. Okay, so first thing you do, always, 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 you're going to start with your equation. Okay, and I'm going to pull this here. So, as I want you guys to know, you can use this with you, right? Because this is so you can look at this and see what it is that you need, or if there is anything that you need to pull out, okay? So we're dealing with a converging lens. And sometimes I like to write this down. So I'm just going to skim you down here so you can see it. I like to write out exactly what kind of lens we're dealing with, okay? So it's a converging lens, all right? So converging lens, hopefully you know, converging lens, it gives you both real and virtual images, okay? Which is good to know because if this is a virtual image, the DI must be negative. Now we're looking for DI, so if it is a virtual image, DI will automatically end up giving us a negative answer, okay? The other thing is F must be negative for diverging lenses. Well, we're dealing with converging lens, so that piece of information doesn't apply to us right now. Okay, so now we can just actually fill it out as we go. So 1 over F, so that's going to end up being 1. I'll just keep going. 1 over 10 centimeters, okay? I'll just fill it out and then I will isolate. Usually I isolate first, so I'm doing it backwards right now, but that's fine. And then 1 over 5. Now we need to isolate. Okay, so tip here, okay? And hopefully you guys have done this in grade 9. I'm almost positive you do this in elementary school. But we're adding and subtracting here, okay? With Snell's law, you were multiplying and dividing, right? Opposite operations. Keep that in mind, opposite operations. But we're just doing we're just doing adding and subtracting. So if it's adding here, we need to get this one by itself, 1 over DI. So we have to get rid of 1 over 5 centimeters. It's adding, so to get rid of it, we need to take it away. But whatever you do to one side, you have to do the other. So it's going to end up being 1 over 10 centimeters minus 1 over 5 centimeters equals 1 over DI. Okay? Hopefully you're following me so far. Let me just move that one down here. Sorry. Okay, so now we have this. Now we need to find our common denominator here. Sorry, it's not super clear. 5 centimeters and 10 centimeters. Well, that's easy peasy. Goes into 10. So we have our 1 over 10 centimeters minus, well, we're going to use 10 as our common denominator. How do we get 10? We have to times by 2. Whatever you do to the bottom, you have to do the top. Goes 1 over DI. Okay? So 1 take away 2 equals negative 1 over 10 centimeters. 1 over DI. Give me a second. Sorry about that. Now we're continuing here. Okay? And when we end up with this, right, how do we get it out from being a fraction? You have to cross multiply. So 1 times di. And I'm just going to do this just so you can see it. Even though you don't need to put the 1 there, I just want you to understand the cross multiply. So, and then 10 times 1, okay? But it's a negative, so that carries over. So I just skipped a step there. Usually you'd keep it with the 1 and be negative 1 over di, and this would be negative. But then you'd have to get it out of being a negative, so you would divide it by a negative to get rid of the negative 1, and then this would end up being negative. But you can move it to the bottom too. So we actually end up with a negative, which is correct because di must be negative for virtual images. Okay, how did we know that this was a virtual image? Well, it's a converging lens, and we know that anything in front of the focal length for a converging lens is going to make a virtual image. If our focal length is 10, sorry, I'm going to keep moving this up. If our focal length is 10 centimeters, okay, and our object is 5 centimeters, our object is in front of that focal length, which means that the image is going to be virtual. How do we get a real image? It has to be behind the focal length for a converging lens. Diverging lens, it can be anywhere, and you're going to end up with a virtual image. Okay, so there's the difference there. So that is question 1.